Download this code from codegive.com, link in the description below. Chunked encoding and persistent 401 unauthorized errors, a deep dive and solutions. Encountering a persistent 401 unauthorized error when using chunk transfer encoding can be a frustrating experience. It often stems from a combination of client and server misconfigurations, incorrect header handling, or subtle issues in how authentication mechanisms interact with the streaming nature of chunked data. This comprehensive guide will dissect this problem, explore potential causes, provide practical code examples, and outline troubleshooting steps to help you overcome this hurdle. Understanding chunk transfer encoding. Before diving into the error itself, let's quickly review chunk transfer encoding. Purpose chunked encoding is a data transfer mechanism in HTTP and other protocols that allows the sender to send data in a series of chunks without knowing the total size of the data in advance. This is particularly useful for dynamically generated content or when the total size is only known as the data is being produced. How it works. One indication the server, or client, indicates its intention to use chunked encoding by setting the transfer encoding, chunked header in the response, or request. 2 chunks the data is sent in chunks. Each chunk consists of chunk size the size of the chunk, in bytes, represented as a hexadecimal number, followed by a CRLF, \r\n. Chunk data the actual chunk data, the number of bytes specified by the chunk size. Chunk terminator CRLF, \r\n, at the end of the chunk data. 3 terminator the end of the entire chunked stream is indicated by a zero-sized chunk, i.e., 0 \n\r\n. This signifies the end of the transmission. 4 trailers, optional after the zero-sized chunk, additional HTTP headers, called trailers, can be sent. Trailers must be declared in the initial header section using the trailer header. Benefits streaming allows sending data as it becomes available, without pre-buffering the entire response. Dynamic content suits situations where the content length is not known beforehand. Resource efficiency avoids unnecessary buffering on both the client and server. The 401 unauthorized error. A 401 unauthorized error indicates that the client has attempted to access a protected resource without providing valid authentication credentials. The server returns the status code when authentication is required but has either failed or has not yet been provided. The www authenticate header is typically included in the 401 response to inform the client of the authentication scheme, supported by the server. Why chunked encoding and 401 errors mix up? The combination of chunked encoding and authentication can introduce subtle challenges. 1. Authentication before full request in many authentication schemes, like basic authentication or digest authentication, the client sends the authorization header before sending the actual request body. With chunked encoding, the entire request body is streamed in chunks. If the server only validates the credentials after receiving the entire request, it might mistakenly return a 401 if it times out or processes only part of the request, not seeing the complete authentication data. 2. Proxy/intermediate server issues proxies and intermediate servers can sometimes mishandle chunked encoding, especially when combined with authentication. They might not correctly forward the authorization header along with the chunked data, or they might strip the header entirely. 3. Stateful authentication some authentication mechanisms rely on maintaining state across multiple requests, example using cookies or session tokens. If chunked encoding breaks the assumption that a request is a single, atomic unit, the server's session management could fail, resulting in a 401. For keep alive connections * chunked encoding is often used with persistent connections, HTTP keep alive. An initial 401 response can poison the connection. If the client attempts to re-authenticate and send another chunked request over the same connection, the server, or an intermediary, might still perceive it as an unauthorized stream, leading to repeated 401 errors. 5. Header corruption or truncation * if there's a problem with the server or client handling the transfer encoding or authorization headers, it can result in a 401. For example, if the authorization header gets truncated due to a buffer overflow or incorrect string handling, the server will not receive valid credentials. 6. Incorrect chunking logic * errors in the client or server-side code that handles chunking, example incorrect chunk size calculation, improper termination, can lead to premature request termination, which might trigger a 401 if the authentication validation occurs late in the process. Practical code examples and solutions. Let's look at code examples in Python and address potential causes of the 401 error in each scenario. 1. Python with requests library, typical scenario. Key points and solutions *. Requests library and stream equals true *. The requests library in Python is very powerful and handles much of the complexities of chunked encoding for you. The critical parameter is stream equals true in the requests.post, or other HTTP methods, call. This tells requests to send the data in chunks. If you omit stream equals true, requests will likely try to buffer the entire data in memory before sending it, which defeats the purpose of chunked encoding. Data as a generator/iterator * the data argument to requests.post, when using stream equals true must be an iterator, or generator. This is essential because requests will pull data from the iterator one chunk at a time. If you pass a regular string or list, requests might not chunk it correctly. The example above uses a generator function, data_generator, to yield chunks of data. Make sure each chunk is encoded to bytes before yielding, encode, UTF-8. * transfer encoding, chunked header * explicitly set the transfer encoding, chunked header in the headers dictionary. While requests might automatically add it in some cases when stream equals true, it's best to be explicit. Content type header * set the content type header appropriately for the data you're sending, example application/JSON, text/plain, application/XML. The server needs this information to correctly interpret the data. Authentication * use the requests.auth.http basic auth class for basic authentication or other appropriate authentication classes / mechanisms supported by requests. Ensure you're providing the correct credentials. Error handling * use try, except blocks to catch requests.exceptions. Request exception or more specific exceptions, like requests.exceptions.http error, to handle potential errors. The response.raise_for_status method is very helpful for raising HTTP errors, 4xx and 5xx status codes, as exceptions. Server-side validation * confirm that your server-side code is correctly handling chunked requests, authenticating users, and processing the data. Use logging on the server to track the request headers, authentication attempts, and chunk processing. Troubleshooting steps with requests. 1. Inspect request headers * use a tool like Wireshark, Dump, or the browser's developer tools to capture the raw HTTP request being sent by the client. Verify that the transfer encoding, chunked header is present, the authorization header is included, and the chunk formatting is correct, hexadecimal chunk sizes followed by CRLF, chunk data, and CRLF. To inspect response headers and body *. Similarly, inspect the server's response headers and body. Check the www authenticate header in the 401 response to understand the expected authentication scheme. If you're receiving a 401, is the authorization header even making it to the server? 3. Simplify the request *. Try sending a minimal chunked request with no authentication first to isolate the problem. If that works, gradually add authentication elements to see when the 401 error reappears. 4. Experiment with chunk sizes *. The chunk _size in the data _generator function can sometimes affect the outcome. Try different chunk sizes to see if one works better than others. Some servers might have limitations on the maximum chunk size they accept. 5. Disable keep alive. For testing, temporarily disable keep alive connections by adding connection close to the request headers. This forces a new connection for each request, which can help isolate issues related to persistent connections and authentication state. 6. Proxy issues *. If you are using a proxy, configure requests to use it explicitly. Also, investigate if the proxy itself is handling chunked encoding and authentication correctly. Some proxies may not correctly forward authorization headers with chunked requests. 7. Server logs *. The most important troubleshooting step is to examine the server-side logs. These logs will often provide clues about why the server is returning a 401 error. Look for authentication failures, errors related to chunk processing, or any exceptions that occur during the request handling. 2. Lower-level example, using http.client and socket in Python. This example provides finer-grained control over the HTTP request but requires more manual handling of chunked encoding. Explanation and troubleshooting tips *. Manual chunking *. This example demonstrates the manual process of chunking the data. You need to calculate the chunk size, convert it to hexadecimal, and send the chunk size and data with the appropriate CRLF terminators. Basic authentication *. The code includes an example of creating the authorization header for basic authentication. *SSL/HTTPS*. The code handles both HTTP and HTTPS connections using http.client.http connection and http.client.https connection, respectively. It also creates an ssl.create_default_context for HTTPS. Error handling uses a try except block to catch potential socket errors, HTTP exceptions, and SSL errors. Key points for troubleshooting correct chunk size calculation double check that you're calculating the chunk size correctly and converting it to hexadecimal without the 0x prefix. CRLF terminators ensure that you're adding the CRLF \r\n terminators correctly after the chunk size and after the chunk data. Authorization header make absolutely sure the authorization header is included in the initial set of headers sent with the request. Connection, keep alive header this encourages persistent connections, which is often desirable with chunked encoding. However, as noted earlier, if there's an initial 401, it can cause problems. If you're having trouble, temporarily remove this header or set it to connection, close for testing. Socket errors socket errors often indicate network connectivity issues or problems with the server. Check your network configuration and the server's availability. SSL/TLS errors if you're using HTTPS and encountering SSL errors, it could be due to certificate issues, incorrect SSL configuration on the server, or a mismatch between the client's and server's supported SSL protocols. Asterisk server-side verification. Asterisk as always, thoroughly examine the server-side logs to pinpoint the cause of the 401 error. Common server-side issues. Even if your client-side code is correct, the problem might lie on the server side. Here are some common server-side issues to investigate. Asterisk improper chunked encoding handling. Asterisk the server's code might not be correctly parsing and reassembling the chunked data. Use server-side debugging tools and logging to trace the chunk processing logic. Asterisk authentication validation logic. Asterisk the server's authentication logic might be flawed, especially when dealing with chunked requests. Ensure that the authentication is performed only after receiving all the chunks, or that the authentication state is properly maintained across chunks. Asterisk timeout issues. Asterisk the server might be timing out while waiting for all the chunks to arrive, especially if the client is sending data slowly. Adjust the server's timeout settings if necessary. Asterisk proxy/load balancer interference. Asterisk if you're using a proxy or load balancer in front of your server, ensure that it's correctly handling chunked requests and forwarding the authentication headers. Misconfigured proxies can strip headers or mangle the chunked data. Asterisk firewall issues. Asterisk firewalls can sometimes interfere with chunked requests, especially if they have strict rules about the size or timing of data transfers. Check your firewall logs to see if any traffic is being blocked. Asterisk resource limits. Asterisk the server might be running out of resources, example memory, file handles, while processing the chunked request, leading to errors. Monitor the server's resource usage. Example server-side code, Node.js with Express. Node.js server-side troubleshooting. Asterisk 1 middleware order. Asterisk make sure your authentication middleware is applied before any middleware that processes the request body, like bodyparser.json, or bodyparser.url encoded. The authentication middleware should be responsible for verifying the credentials before the body is parsed. 2 chunked data aggregation. Asterisk in the /API/chunked endpoint, the example code aggregates the chunks of data into the request body variable. This ensures you have the complete request body before parsing it. 3 error handling. Asterisk the code includes error handling for JSON parsing and request errors. 4 logging. Asterisk add extensive logging to your server-side code to track the request headers, authentication attempts, the incoming chunks, and any errors that occur. 5 authentication validation. Asterisk replace the placeholder authentication logic, username == your _username and end password == your _password, with your actual authentication mechanism, example database lookup, JWT validation. Summary and best practices. Asterisk use stream =true and iterators/generators on the client side, requests library. Asterisk set transfer encoding, chunked and content type headers explicitly. Asterisk include the authorization header in the initial request headers. Asterisk handle chunked data aggregation correctly on the server side. Asterisk implement robust error handling and logging on both the client and server. Asterisk inspect request and response headers using network analysis tools. Asterisk thoroughly examine server-side logs for clues about authentication failures or chunk processing errors. Asterisk test with simplified requests and gradually add complexity. Asterisk be aware of potential proxy/load balancer/firewall interference. Asterisk consider using HTTPS, SSL/TLS, for secure communication. Asterisk for persistent connections, make sure authentication state is maintained properly. By carefully addressing these potential issues, you can diagnose and resolve persistent 401 unauthorized errors when using chunk transfer encoding, ensuring seamless and secure data transfer between your client and server. Remember to isolate the problem, inspect the traffic, and analyze the server logs. These are your most valuable tools for troubleshooting.